Good morning, I'm Silvia Pisani, postdoc research fellow at San Matteo Hospital in Pavia, Italy, and my research work focuses on tissue engineering and regenerative medicine. More in detail, I'm going to present my research focused on mesenchymal stem cell engineered tubular scaffold for esophagus circular resection replacement. The esophagus is a muscular tube connecting the pharynx with the stomach, allowing food passage. Esophageal cancer is related to abnormalities, mutation in the DNA cell, and the two most common types of esophageal cancer are the squamous cell carcinoma and adenocarcinoma. So esophageal cancer is an aggressive malignant tumor that starts in the lining of the esophagus and following growing affect the muscle and the tissue, causing metastasis spreading. Esophageal cancer is the fifth leading cause of cancer death in the world, and incidence rate for esophageal squamous cell carcinomas in men show highest incidence rate from Eastern to Central Asia, Indian Ocean coast of Africa, and South America. Current esophageal cancer treatment requires surgical operation to remove the major cancerogenic portion of esophagus. Performing traditional esophagectomy, esophagus is replaced using another organ like stomach or intestine. Unfortunately, this approach exhibits some limitations, such as stricture formation, nerve injury, acid reflux, leakage from the surgical connection, and so on. For this reason, an alternative tissue engineering approach is required to overcome postoperative complications and promote restoration of physiological function. So my contribution focused on preparation of biocompatible and biodegradable polymeric electrospan tubular scaffold to be used as full thickness esophageal substitute. Electrospan nanofiber were collected using a rotating cylindrical membrane in order to achieve scaffold with suitable diameter and thickness. Morphological characterization show a nanofiber, a nanoarchitecture with random fiber orientation able to mimic the natural extracellular matrix. So inner portion of tubular scaffold was cellularized using mesenchymal stem cell, and proliferation and cell interaction with scaffold was evaluated by actin DAPI staining and SEMA analysis. Tubular scaffold were also characterized for their mechanical property and resistance to axial tensile stress, and data were compared with those obtained for PICS esophageal used as reference control. In promising result obtained from in vitro characterization allow us to perform a preliminary in vivo study using a baby pigs animal model, and we are continuing to work in a multidisciplinary field to achieve more performing engineering tubular scaffold for esophagus regeneration. Thank you for your kind attention.